Okay, so they gave us a 3 by 3 matrix, and they want us to find the inverse, A inverse, if it exists. Now, we don't really have a way yet to determine whether a 3 by 3 inverse actually exists. We will learn that in the next section. So for now, we're just going to assume that it exists and go ahead and solve for A inverse. And then, after we find it, we are going to verify that our answer is good. Okay, so let's do the first step, and that is to begin with the matrix A, and right beside it, we're going to put the identity matrix for a 3 by 3. And then we'll work on it. All right, so what is this equal to? It's equal to 1 down below 2, down below negative 3, and then negative 2 down below negative 3, down below 6, and then negative 4 down below negative 6, down below 15. I'll put my dotted line here, and I'll write the identity matrix. 1 down below 0, down below 0, 0 down below 0. I'm sorry, there's a 1 here. There's a 1 here. 1's on the diagonal, right? Down below 0. And then 0, down below 0, down below 1. That's the identity matrix for a 3 by 3. Okay, so now step 2, we're going to do row operations to get the result, which will be the identity matrix will be in the front now, and there'll be some matrix in the back, which we'll call B. Okay, and we're going to do that step by step. Now you can see we don't have to work on the upper left entry because that's already 1. We need to start here with the entry 2. To do that, I'm just looking at the darn thing and I'm thinking, you know, if I took row 2, and by the way, let's label the rows. This is row 1, row 2, and row 3. If I take row 2 and I subtract 2 times row 1, that will become my new row 2. And I will have accomplished, or be on my way to accomplish, a 0 in the position that I've circled. Okay, so I want you to do the work on the side. I am just going to put the result. Row 1 is totally unchanged. 1, next to that negative 2, next to that negative 4, next to that 1, next to that 0, next to that 0. That's my row 1. Now, row 2 is changing. It is the result of taking our row 2 from the first matrix above, step 1, and subtracting 2 times row 1. The answer goes in row 2, which is what I'm writing now, a 0, and then next to that a 1, next to that a 2, next to that a negative 2, next to that a 1, and next to that a 0. That is my, let's see if I got that right, 0, 1, 2, negative 2, 1, 0. Yeah, that's my new row 2. And row 3 is unchanged. Just bring it down. Negative 3 down below, and then next to that 6, down next to that is 15. Next to that 0, next 0, next 1. That's row 3. So that is the result of doing this row operation. Okay, what are we concentrating on now? Now, we got to be careful when we do this that we don't introduce new issues that we have to worry about that will undo all the work we did before. So be careful. Let's work our way down very systematically. We want that entry, negative 3, to become a 0. And by inspection, I see that if I do this row 3 plus 3 times row 1, and then take the result and replace row 3, I'll have what I want. So let's do that on the side somewhere and just write down the result. Okay. First row will be unchanged. Second row unchanged. Last row will be changed. Okay, so first row is 1, next to that negative 2, next to that negative 4, next to that 1, next to that 0, next to that 0. That's our row 1. Row 2 is unchanged. 0, 1, 2, negative 2, 1, 0. That's our row 2. And now row 3 will be removed and replaced with the result of our operation, which gives us 0, and then next to that a 0, and next to that a 3, and beside that a 3, and then a 0, and then a 1. That's our new row 3. And we accomplished what we intended to. We got a 0 in place of the negative 3. Now, let's go up here to this location. What do we want that value to be? We want it to be 0. How will we get it to be 0? Well, actually, it's pretty easy to get that to be 0. All that we have to do for that is row 1/3 times row 3 becomes our new row 3. See, we can do that. We can multiply any row by a number and replace the row with that. Okay, so we're going to replace row 3. Now, I spoke too soon. We're not actually doing this. We are working on changing this guy to a 1. First, we decided to change this guy to a 1. And then we'll worry about the guy where I put the X. Okay, so this is going to get rid of that 3. It's going to make it into a 1 because we want 1s on the diagonal, right, guys? 1s on the diagonal in order to get the identity in this position. All right, let me bring down my dotted line. Okay, so that's why I did 1/3 times row 3, moving into the position of row 3. And that will give us the following result. It will not change row 1, 1, and next to that -2, and then -4, and then 1, and then 0, and then 0, row 1. Second row, unchanged. 0, 1, 2, -2, 1, 0. That's my row 2. But look what I get now for my new row 3. The result of 1/3 times row 3 gives me a 0 here, and then a 0 here, and a 1, which is exactly what I wanted to replace the 3. And continue, I have a 1, and a 0, and 1/3. That's my new R3. Now I'm going to work on that guy up here that I mentioned too soon in the last step. I want that to be a 0. And to get that, I'm going to do the following. I'm going to do row 1 plus 2 times row 2, and that will replace row 1. Okay, so the only thing that's going to change here is row 1. And I'll do that right now. Row 1 will be 1, and then beside that 0, and beside that 0, and then a -3, and then a 2, and then a 0. That's my new row 1. Row 2 and row 3 are unchanged. 0, 1, 2, -2, 1, 0. That's row 2. And finally, 0, 0, 1, 1, 0, 1/3. Unchanged. That's row 3. Okay, now I think I'm going to start a new video to continue this. I'm looking really good here. And the next guy that I am going to work on, I'll tell you right now, is going to be that dude right there. I want him to be a 0. And when I get him to be a 0, I will be there. I wonder if I should do it. Yeah, let's go to a new video. We'll get that to be 0.